Welcome, my name is Jerry Sunarine, and today we're going to be looking at how can you subtract mixed numbers more efficiently. Before we get into today's lesson, I'm going to go over some vocabulary that will be helpful for students to understand and make sense when going into today's actual lesson. Some three vocabulary terms that's going to be used in this lesson is proper fractions. Of proper fractions is a fraction in which the numerator is less than the denominator, and it's important to notice that the numerator is 3, the denominator is 4, 3 is smaller than 4. Improper fractions is a fraction in which the numerator is greater than or equal to the denominator. Here we see that 12 is our numerator, 5 is our denominator, and 12 is larger than 5. The last is mixed number, a number that contains a whole number and a fraction. Here we see that 7 is a whole number, and we can identify it as a whole number because the number is written larger compared to the numerator and denominator. Numerator 2, denominator 3. Now we're ready to jump into today's lesson. When reading the question, it's important that students are able to read the problem several times in order to make sense of what the problem is asking them. If they're having trouble, you as the teacher can provide them examples of what do we think is happening in this problem. Do we have more pizzas in the end? Do we have less pizzas in the end? What's happening? Can we tell a story? And this will help students to help annotate, make sense of the fractions, and what do they need to do to develop a skill set in order to answer the problem. In the directions, we notice that we want students to read the story at least 3 times. And again, this is just to encourage them to make sense of what the problem is asking. So I'm going to show you 2 ways we can show and do this problem in addition to reading the problem and making sense of it. First is going to be a visual. Here's a visual diagram in order to make sense of the problem. We see that there are 4 1/8 pizza, and I provided a diagram of 4 whole, 1, 2, 3, 4, and 1/8. So 4 1/8, and then we notice that Benny took 2/8. I noted that B is Benny, and we notice that he took 2 of the slices. We can have students identify how much pizza is left, and we would arrive at the answer of 3 7/8. The next way of doing this is algebraic. So just in case if it might be too much work for students to draw out the diagram, using an algebraic approach can help them get to the answer the same way. Here I provided some steps. When working through the problem, we want to think about rewriting the first fraction, and we can explicitly tell students you borrow 1 from the whole number and making the proper fraction into an improper fraction. Here we start out with 4 1/8. Here we have it, and we're going to convert it to 3 9/8. Showing them that process is going to be the most important part of this process. So for example, we borrow 1 from 4 to get 3, and we notice that that 1 turns into 8 over 8, and we're going to add that to the 1/8. The 1/8 comes from the actual problem, so we're not choosing a random fraction. We add across 9 over 8, and we also want students to identify that the denominator determines how the borrowed 1 will look like. So since the denominator is 8, that tells us we're going to turn this fraction from 1 into 8 over 8. Therefore, our new problem will look like 3 9/8 minus 2 8 equals 3 7/8. For students who will be interacting with this problem, starting at this step can help them subtract the 2 fractions. And then from here, you can work backwards by having the students derive from 3/9/8 to getting it from 4/1/8. So starting out with this might be a little easier for students, and then working backwards to get to having students start with 4/1/8 to get this fraction in order to subtract effectively. And this is more of a scaffold approach. I'm going to provide two more examples. Here's one example, and we again use the same steps, 2 steps, and it's important for us to write down few steps for students to follow in order for them to make sense of how to work through the problem. And here's another example. And here we see that if we're starting out at 11/1/5, we need to convert this first fraction by taking 1 from 11, turning it into 10. And remember, the 5, the denominator, is going to tell us how we're going to change that fraction. So 5 over 5, 5/5, plus 1/5 equals 6/5. Therefore, that's how we have 10 6/5. We're going to keep the second fraction the same, and we want students to subtract like terms. Here we see 10 minus 2 equals 8, 6 minus 3 equals 3, and we want students to identify whole number minus whole number equals whole number, numerator minus numerator equals numerator, and we can have students identify that nothing happens with the denominator. You just write it over, and that will be your final answer. Now we're going to just move on to the summarize page. Here, how can you subtract mixed numbers more effectively? Again, we looked at visual models, but we can also look at the steps provided so that students can follow a guide in order for them to work through the problem on their own. Here are some examples, and providing students examples here, and then having them work back to the problem to change a mixed number into an improper fraction can be more advanced for the student, as long as they know the process and to practice the process over and over again with several examples. Hope this was helpful, and have a great day.